Hi everyone, welcome once again to our series on basic mechanics, and we welcome you once again to our channel. Kindly subscribe, like and share as well. Today we are looking at moment of a couple, resultant of couples in 3D. Let us look at our question and how we are going to solve it. Determine the single couple moment that can replace the couple system shown. So we have our system there. Now let's see how to analyze the question. Good. So you have seen that in this case, we have the diagram there is 3D. We have the x-axis, we have the z-axis, and then we have the y-axis. So if it is a 3D object and you want to find the resultant couple, you can use the scalar method and you can also use the vector method. So in this question, we are going to see how to solve the problem using both scalar method and vector approach. So let's start with the scalar approach. The scalar approach. Now, we see that this and that is forming a couple. This and that is also forming a couple. This and that is also forming a couple. Therefore, in the scalar method, what we need to do, sorry for that, we are still using the scalar method. We are still using the scalar method. So what we are going to do is that we are going to analyze the individual couples separately. So first of all, let's start with the 400 Newton force or 400 Newton couple. So we realize that, look at the direction of the force. The force is in the y-axis, and in the same way, this force is also in the y-axis. You can see that this is our y. So all these two forces are in the y-axis, and the perpendicular distance between the two is now in the z-axis, as you can see. So it means that our force is in the x, in the y, our force is in the y, and our perpendicular distance is in the z. So we said that if this is y and this is z, then our rotation will take place in the x direction, in the x-axis. So we can say that the 400 will give us moment in the x-axis, which is going to give us mx, moment in the x-axis, will be equal to, don't forget that we are taking the anti-clockwise to be positive. So ms is equal to 400. We know that the formula for finding moment is b times f. So it means that here our moment is going to be 400 times the distance between them, which is 4. And let's look at our direction. Is it going to be clockwise or anti-clockwise? I've already established the fact that always use one of the forces to determine whether it's going to move in the clockwise direction or in the anti-clockwise direction. So in this case, we have a 400 force applied this way, and then the perpendicular distance between the two couples is like this. So you can see that, let's take it that this side is fixed. So when you apply a force, it's going to rotate the object in this direction, which means that it's going to be in the anti-clockwise direction. Therefore, our moment here is going to be positive, which is going to give us 1,600 Newton meter. We said that the moment will be in the x-axis, so this will give us I. It will give us I. Now let's go to our 100 Newton couple. So for the 100 Newton couple, now we see that the forces are in the x direction. You can see that the forces are in the x direction. You can see that. So our force is in the x, and then the distance between them is in the y. The distance between them is in the y. So we said that if that is the case, if the forces are applied in x and a perpendicular distance is in the y, then we are going to get rotation in the z. Therefore, we can say that mz will be equal to, the force is 100 and the distance is 2. So 2 times 100, which is going to give us 200 Newton meter. But now we said that the rotation will be in the z. So we attach our k to it. It means that it will be in the k direction. But let's check whether it will be clockwise or anti-clockwise. You see, we have said that we pick one of the forces. So let's take it that this is our force here, and this is the distance here. This is the distance, perpendicular distance. So if I apply the force here, you will find out that this force here is going to rotate the object in this direction, and this direction is anti-clockwise. So our moment is going to be positive. Now let's do for the last force, which is the 300 and the 300 couple. So for the 300 Newton couple. Now you can see that the first two examples you have worked it out, there was a perpendicular distance between the two forces. But in this case, from this force to this force, you can see that we don't have any one particular perpendicular distance. We have one distance going this direction and another distance going this direction. So it makes it very difficult for you to determine the perpendicular distance. Therefore, anytime you get a problem like that, what you need to do is to attach two equal but opposite forces at the junction of the two couples, So here you can see that the junction of the two couples are this side. And we are saying that we are going to attach two equal but opposite forces, which is equivalent to our 300 newtons there. So this is going to be 300 newtons, and it should be in the same axis with our forces. So the other one here is also going to move down like that, and that is also going to be 300 newtons. Now you can see that this and that are forming a couple, and this and the one up here is also forming a couple. So we can use this and that, and then we know that if you are using this and that, the perpendicular distance between them is 5. And if you are using this side and that side, and the perpendicular distance between them will be 3. So we have been able to separate that side into 2. Let's determine our moment for the 2. Now you can realize that we are using this and that, as we had clearly indicated. We said that we are attaching two equal forces at this side. Sorry, I want it to be clear. That is why I want to clean that side and redraw again. So we said that we are attaching two equal but opposite forces, one in this direction and one down there, and this is 300 and this is 300. You can see that this and that are forming a couple, and they are all in the y-axis. So our force is in the z. In this case, is the z. Our force is in the z-axis. So force is in the z, and then the perpendicular distance between them is in the y. So you can see that our rotation is going to be on the x. Therefore, you can write mx will be equal to the magnitude of our force, which is 300, times the distance between them, which is 5. And we can check whether it to be clockwise or anti-clockwise. We said that you always use one of the forces. So here, this is our distance. So let's take it that our distance is here. And then from the principle of transmissibility, we can bring this force up here, so far as it has the same direction. And you realize that when we bring the force here, it is going to rotate the distance. This side is fixed. So it's going to rotate the object in this direction like this. And so it's going to be anti-clockwise, which will make the whole thing positive. Therefore, we are going to get ms to be 1,500 Newton meter I. And then we do for the other side, which is this one and that one. Now the forces are still in the z direction, but now our distance, the perpendicular distance between the two of them is in the x. Therefore, our rotation is going to be in the y. So we can say that our my will be equal to the 300 times the perpendicular distance between them, which is 3. But now let's look at the direction. If we apply a force down here, so our structure is like this, we are applying a force here, and this side is fixed. If we apply a force here, you realize that the rotation is going to be in this direction, which is clockwise. Therefore, our answer is going to be negative 900 Newton meter, and we said that the rotation will be in the y, so J. Now that we have been able to do for all the different forces, we just have to put them together to find the single couple. So you see that we have x here, and then we have x here. We have x here, so we can put the two together, which will be 1,600 plus 1,500 I, and then we only have one j. So we have negative 900 j, and then we have only one z, which will be 200 k. Then from here, our resultant moment is going to be 3,100 I minus 900 G plus 200 K. And from here, we have been able to determine our resultant moment using the scalar approach. That is very simple. Let us try and see how we can also do the same thing for our vector approach. And let's see how to use the vector approach to get our resultant couple. Now, for the vector approach, don't forget that we said that if you are determining the moment for the scalar approach, the direction of the force is not important, and the direction of the distances is also not important. But when we are using the vector approach, the direction of the forces are very important, as well as the direction of the distances. So our distances are going to be like this. So on the x, now this is our z. Anytime you are moving up, it will be positive. This is our z axis from the question. And anytime you are coming down, will be negative. This is our y axis. Anytime you are going this direction, will be positive. Anytime you are going this direction, will be negative. And then our x is in this direction, positive. And anytime you are going this direction, will be negative. So we are going to apply these directions to both our distances and our forces. That is for the vector method. It is very important. Anytime you are using the vector approach, you consider the direction of the forces and the direction of the distances. But that is not so with the scalar approach. So now let's take a look at them one after the other. So firstly, we are going to take moment at one point. In the vector approach, we take moment at one point. So we can always take the moment at the point which will eliminate most of the forces. Here you realize that at point Z, at point B, we have two forces, and at point O, we have two forces. So we can decide to take the moment at point O or take the moment at point B. So, but in this case, let's take a moment at point O. So taking moment at O, taking moment at O. If we decide to take moment at O, now let's consider our forces one by one and then see how to resolve them together with their individual directions. Yes. So from here, you can see that we are taking a moment from O, this point. So it means that this force will go to 0, this force will go to 0. We are left with 4 forces. First of all, let's take this force. This force is in the y-axis. Look at the direction. It is going in the negative direction of our y. It means that our force is going to be negative 400. And it's in the y, so we represent it with J cross the distance from where we are taking the moment. Take note, it is always the distance from where you are taking the moment to where the force has been applied. So you can see that here, moving from O to where this force has been applied, we are going to move up like that. And because you are moving up, it is not where the force is applied to O, but rather where we are taking the moment to where the force has been applied. So you can see that if you want to go to where the force has been applied, you'll be moving up. Therefore, our distance is going to be up on the z-axis, and we said that up on the z-axis is positive. So you are going to get 4. The distance is 4, and it's in the x-axis. Okay. And then we are done with that force. We come to our second force here. Look at the direction of the force. It is in the x-axis. And we said that anytime x is moving this direction, it's going to be positive. So look at the force here, it is moving that direction. So it's going to be positive. Therefore, we are going to get 100, and it's in the I. So we call it I cross. Now you can see that where we are taking the moment is at O. Where this 100 has been applied, it means that we said that you always move from where you are taking the moment to where the force has been applied. So in this case also, we are going to move from this point to where the force has been applied, which means that we'll be moving up. And once you are moving up, you will get a positive answer. So we have 4, and it's in the z-axis. So okay. And then we go to our third force, which is this one. Now we are also seeing that it is in the x-axis, but now in this case, it is moving in our opposite x-axis. It is moving in this direction. And we said that when you are moving this direction, our force will be negative. Therefore, you are going to get negative 100 I cross. Now, the distance from where the moment we are taking the moment to where the force has been applied, you realize that we move up like this on the y, up like this on the y, up like this on the z. Sorry, this is our z-axis. This is our z-axis. So we are going to move up on the z. Let me clean that one, and then we'll quickly see how we are going to deal with that. So you can see that we are moving from this point to that point. We are going to move up on the z, and then we said that up is positive. So you are going to get 4k, and then from there we move this distance on the y. Move this distance on the y, and we are moving in the same direction with our positive y-axis. So we are also going to get plus 2j. And then we come to our last force here. Look at the direction, it's in the z-axis, and it is going up. So we said that if it's going up, it's going to be positive. Therefore, we are going to get 300k, it's in the z-axis. Okay, cross into brackets. Now, where we are taking the moment to where the force has been applied, you realize that we move this distance on the y, and it is in line with our positive y-axis. So that distance is going to be positive j. And then we move this distance on the x. Look at the direction. We are moving in the same direction with our x-axis. So it's going to give us plus 3i. And from here, we said that you do the computation, but for you to get I cross j, we said that you can use this method I, j, k. And anytime you are moving anti-clockwise, it's positive. So here you have negative 400j times 4k. That is going to give us negative 1,600. Negative 1,600. But this one you have j cross k. So j cross k will be moving this direction, which is anti-clockwise. and j cross k anti-clockwise, so our answer is going to be positive I. Positive I. Then we have 100I cross 4k. 100 times 4 will give us 400, but I cross k, here, where is our I? This is our I. So I cross k, we will move this direction, which is clockwise. Which is clockwise. Good. So 100 I times k is clockwise, so we are going to get negative 400 j. Negative 400 j plus negative 100 j times 4k. We are going to get negative, it's going to give us negative 400, but I cross k will give us I cross k. It's also going to be in the negative. I cross k is going to be in the negative direction, which is in the clockwise direction. Therefore, this side is going to give us negative j. So the negative there will make it positive. So let me clean the negative so that our answer there will be positive. And then we can also do for what is down here. We have negative 100j cross negative 100I cross 2j. So you are going to get negative 200k I cross j is in the anti-clockwise direction, which means that our k will be positive, plus now 300 times 5 is going to give us 1500. We have k cross j, so k cross j is going to be in the anti-clockwise, which is going to be positive. Positive we have, which is going to be no k cross j will be in the clockwise direction. It's going to be in the clockwise direction, which will give us negative I. And then the last one, we have 300k times 3I, and that will give us 900. But k cross I will be in the anti-clockwise direction, which is going to be positive j. Then from here we add all of them together, and from here our final answer is going to be negative 3100I plus 900j minus 200k. So here when we divide through by negative, we are still going to get our answer as the one we got for the scalar approach, which will give us, when we divide through by negative 1, we are going to get 3100I plus minus, because we are dividing through by negative, so we are going to get minus 900j plus 200k. And we are done. You can see that both the scalar and then the vector approach is giving us the same answers. So that is pretty simple. If there is any comments, suggestion, or anything like that, you can let us know at the comment section. I will be glad to assist you to understand whatever is bothering you. Once again, thank you for watching, and thank you for staying in touch with us and always looking forward for our videos. We are very grateful. So thank you for watching. Kindly subscribe to our channel and hit the notification bell. See you in our next video. Bye-bye.